The government analyzes the possibility of introducing a new tax depending on the income I and the properties P. This tax must be proportional to the squared difference of them. Will this tax be negative in any case? To solve this exercise, we must know what does proportional mean. Identify a quadratic form, which you can find in tutorial of Unit 2, definition 24. Calculate the matrix of a quadratic form, definition 26. Use the minus method to study the sign of a quadratic form, property 35. And interpret the sign of a quadratic form, definition 30. So, we are asked to calculate a tax function that I'll call t, which depends on two measures, income, I, and some properties, P. We are told that this tax must be proportional to the square difference of them. So the difference of them is I minus P. This is the square, and a term proportional to this expression is a number k by this square difference, being k some number in R. I calculate now this expression. T would be k times I square minus 2ip plus p square, which is ki square minus 2k ip plus k p square. To identify this expression, you must bear in mind that k is a parameter and the variables are y and p. So I have here a 2-degree term. Here there is another 2-degree term, and here another one. So t is a quadratic form. To study its sign, I first calculate its matrix. The term in the first variable square is this one, so I write here k. The second variable square has a k as coefficient as well. And finally, I times p has minus 2k as coefficient. That divided by 2 is minus 1 and minus 1. So here we have its matrix. As it depends on a parameter k, it's better to use the minus method. So I calculate the first one is k, and the second one is k square minus 1. I'm sorry, here there is a mistake. I forgot that the coefficient is minus 2k. So this is wrong. And this one as well. This coefficient is minus k and minus k. So the second minor is wrong as well. It is k square minus k square equals 0. So the minors are k and 0. Then we are interested in studying the sign of these minors when k is less than 0, exactly 0, and greater than 0. Case 1, k less than 0. In this case, A1 would be negative, A2 is always 0. Using the minus method, we have that the quadratic form is indefinite. No, sorry, this would be negative semi-definite. If you have any doubt with this, you can use the eigenvalues method as well. This was the matrix. The characteristic polynomial is k minus lambda minus k minus k, k minus lambda, which is k minus lambda squared minus k squared equal k squared minus 2k lambda plus lambda squared minus k squared. So lambda as a common factor of lambda minus 2k. The eigenvalues are 0 and 2k. So if we are in the case in which k is less than 0, this would be less than 0, and we would have a null eigenvalue and a negative eigenvalue. So t is negative semi-definite. So when k is less than 0, we have that the tax is negative semi-definite. Now we study the case where k is 0. In this case, if you have a look to the function, to the quadratic form, this was k times I minus p squared. So if k is 0, this result is 0, which doesn't make any sense in this case. This means that t would be a null tax in any case. Finally, we must study the case where k is greater than 1. In this case, we have a positive, A2, 0. Using the minus method, t would be positive semi-definite. So, case 1, t is negative semi-definite. Case 2, we have a null tax, and case 3, we have that t is positive semi-definite. The question was, will this tax be negative in any case? So the answer would be yes. The tax would be negative if k is less than 0. The tax would be negative or null if k is negative. Proportional means multiplied by a real number k. If you are not sure about your answer when using the minus method, remember that you can try as well with the eigenvalues method. And finally, to study the sign of a quadratic form which depends on unknown parameters, you must study the different cases existing for it.